Alright guys, I'm going to make a quick little video to give you guys an introduction to transformation or transforming nonlinear data into a linear form. And this is important for biomedical engineering because a lot of the real world applications that we use, the data that we receive will be in a nonlinear form. Alright, and a lot of times we want to get it into a linear form so we can understand the relationships between variables. Alright, and for instance, let's say that we have a set of data where we're maybe working with a bioreactor and creating some products. And if I were to plot that data, all right, where I'm looking at X versus Y, all right, and I was creating products, I might see some type of um, exponential relationship between X and Y. All right, and maybe that same bioreactor is going to equilibrium, and if I were to plot that as a function of X versus Y, I might see an equilibrium data that might look something along those lines. And then just to drive this home, if I'm creating some type of product, I'm probably consuming also some type of substrate as well in this bioreactor. And if I was to plot that data as a function of X versus Y, I might see something that looks along the lines of this. All right, and as you can see in each of these three examples, these are non-linear plots, okay? And so we want to try to also look at the linear form of these. And in general, what I'm going to be doing is either manipulating, all right, the y variable or the x variable, or I can manipulate both, all right, depending on how severe I need to linearize this data and get a linear form. Right. So if I took, for instance, this example where we're creating products here, and I were to look at trying to transform this data, I may plot y against x squared, all right, instead of the x. And if I did that, I would end up getting a linear form. Same thing if I was to look into the exponential or the equilibrium uh, example here. Instead of plotting y versus x, maybe I plot at y versus the square root of x, and this would result in a linear form. And then lastly, in my substrate problem, where instead of y versus x, I might plot y versus 1 over x, and this would give me a negative linear form here, negative linear slope. And so for these problems, instead of having y equals mx plus b like we have up here, for this particular one we have y equals mx. Oops, sorry about that. X squared plus b. All right, so this is just a quick little introduction. In the next couple of videos, I'll give you guys some actual real-world examples of transforming equations into linear form.